All right, this topic is the shielded metal arc welding process. And Smaw, again, you would see this on the tail end of a welding symbol. Or if it's considered more of a standardized, it just wouldn't be shown at all unless something else was there. Because Smaw is basically a very straightforward and very accepted process. One of the advantages of shielded metal arc welding is the fact that you don't have to have that much equipment. In fact, it can be compacted down into a little setup just like this. You know, one little box, 2 leads, and some electrical power, and you are set up for doing some welding. So the economy of it's great as long as you have electricity. Now the shielded component of it is best described as this. Look at this little graphic here. In the welding process, when an arc is struck, that shielding component is the gaseous shield that occurs from the actual weld itself. The arc essentially is shielded by the decomposition of the electrode covering. So this covering, or this flux, as it decomposes in the arc, it creates a shielding effect. So the heat gets generated straight down into the molten material of the surface, and your slag comes out on top, and your filler, your actual material, gets used into here. So here comes the filler, here's your base. Let me use my little button here. This is your actual filler component. This is your flux. It gets combined with your base down in here, and your slag is the covering there. But this zone, as this arc occurs, is a shield. So what actually happened in the way this was discovered, essentially, was that there was an older process that used an arc type welding to occur. But what was found is that if we run electrons and conduct electricity through the metal plate, then that actually creates a molten effect where actually when it arcs through that point, as the positive electrons run to the negative electrons, you basically get this arc effect, and it ended up melting the steel. So what they discovered was, hey, we can turn this fact that this happens into a welding process because this arc occurs. Now for some quick terminology associated, we are dealing with electricity. Let's just hit a couple of components here. First of all, you've got the A, which stands for amps. Now you'll notice on most arc welders that they're going to have a control for amps, and the Smaw process does have a range of typically 50 amps on up to possibly 200 amps, and that is, draw it there. Amps is essentially, if you want to understand the term of it, it's the amount of electrons flowing through a space over a period of time. So it's like, if you were to look at it in comparison to a pipe, let's do that. Let's just take a pipe, for example, a water hose even. We take a water hose, and out comes water, right? The amount of water flowing through the pipe is the equivalent of electrical current. It's the amount of electrons flowing through the conductor. So when your amperage starts to go up, you're flowing more and more and more electrons through the same size conductor, which eventually causes it to burn up. Now that's different than voltage. To actually use the same comparison of the water hose, voltage is like the water hose pressure. So for example, if I take my water hose out in the field here, and I turn it on and I shoot the water this far, and it only goes that distance, that's a certain amount of pressure that the water is under to how far it goes. If I turn up the pressure, like add a pump to it, here's my P for pump, and increase the pressure, I can still have the same flow, but I actually have more pressure shooting out. In fact, actually there's a ratio of well, I'm going too far, but essentially your voltage is your pressure, your amperage is your flow. We'll keep it simple like that. So there's your equivalent between voltage and amperage. The voltage actually is not what's dangerous for a person, it's actually the amperage. And the amperage is essentially what burns up conductors, not so much the actual voltage or the pressure. So there's a little electricity lesson for you, because as you can see, when dealing with arc welding, we're going to have to be dealing with electricity. Now let's take a look at a couple key things about shield metal arc welding equipment that involves their electricity and some of the terminology there. So we'll just use this as a reference. Go ahead and view those things. So let's start off with the equipment in terms of the way the current, and a current is your amount of amperage, your flow of electrons through. Let's talk about the way it works. There are two terms for current associated with this. One, of course, is DC, and one, of course, is AC. DC stands for direct current. AC stands for alternating current. So what we're saying is direct current actually flows from one spot. Well, let's do it. Here we have a pipe, and we're going to call this spot 1 and spot 2. Direct current, or DC, flows in one direction only. It never changes. It goes from 1 to 2 all day long, never changes. AC, however, actually changes. So in one instance, it might be flowing this way, and then in another instance, it might be flowing this way. And then it's going to turn around and go back this way, and then going to turn around and go this way. Alternating current, as it implies, alternates from one direction to the other. So, and there's advantages in terms of electricity. You can study up on that. There's plenty of history lessons as to why we have direct current versus, or why we have an alternating current versus direct current, both of which were proposed as ways of lighting up cities and towns and houses and using electricity. But that's your major concept. Direct current, one direction only. Alternating current switches direction back and forth, this way or that way. Depends on how many times a second it changes. And with AC in the US, what's actually happening is the current changes direction 60 times a second. And that's why we refer to as a current being a 60 hertz system. So within a 1 second's time period, the current goes this way, and then this way, and then this way, and then this way, and then this way, and this way, 60 times in 1 second. Now, as far as welding machines and how they use this, they can actually operate in different ways. So, for example, if a welding, which most of the ones that are kind of like this are going to be typically running in a specific application. Just to break it down just a little bit, for example, a welding machine can be of a transformer, or a generator, or rectifier design. Transformer means that it's producing AC current only. So an example is when you hook up the electrode, and I need to draw here. If I hook up the electrode, here's my plate, and here's my clamp, my grounding clamp. There's its end, and here is my electrode. The electricity is going to be flowing from this one this way, right? So if it's direct current, it's always going this way. If it's alternating current, it goes this way, then it goes this way, and then back and forth, as we just learned. And if it's a transformer type of machine, it's actually going alternating current, so it's alternating direction. So one moment it's this way, and then one moment it's this way. Now that's if it is a transformer welding machine. If it's a generator welding machine, then it's running on DC. Or that it's producing DC. When I say producing, keep in mind these machines are plugged in to an electrical supply, but they may convert the electrical format before using it. So the machine itself might be a transformer or a welding machine or a generator. If it's a generator, that means it's producing DC, which means the current's always going one direction all the time. A rectifier design is a welding machine that produces either or. Now the rectifier term is an electrical term, which means it can rectify, if it's dealing with AC or DC, it can turn it into one or the other. So what they're saying is that particular machine can produce direct current, one direction all the time, or it can produce alternating current and change directions all the time. Your type of equipment is based on where you're located, what your process is, and that sort of thing. But in terms of terminology, transformer is producing AC current, generator is producing DC current, rectifier can do either or. Another key point to understand about equipment is what type of power do you have to hook up to it to get what you're after. So for example, can you generate enough, if you're in the field, can you generate enough electricity to run the equipment? So for example, a little tool here. Welding machines commonly use a range of voltage from 220 to 440. Most welding machines, like your typical buy in the store, or, the ones you'll see around farms, those kind of things. Ours, for example, runs on 220. However, your more industrial applications can crank up and work off 440 voltage. Now, this is not current, this is the voltage. This is the amount of pressure they have access to. They do have to comply with the National Electrical Code in Article 630. That's a big bunch of pages involving these type of machines and all kinds of stipulations about that. But you don't typically have to worry about that so much, is because the machines are made to meet these requirements before you can ever buy them. There are units actually that can run on lower voltage. You know, some of these ones that you can purchase that are really small, they can actually run off a very I've actually seen one that can run off a 110 or 120 volt. Some of them actually run off just a 220, but it's actually a low amperage welder. How about this? This is a good stopping point. Let's take a break, and we'll catch up on this equipment with duty cycle on the next one. See you then.